Imagine you're a curious explorer venturing into the wild jungle of your own mind. That's what neural networks are all about, AI's way of mimicking how our brains learn and think. Hi, I'm your guide on AI Explained Simply, and today we're decoding how these digital brains work. Picture this, just like neurons in your head firing signals to help you recognize a friend's face or decide what to eat for lunch, neural networks use layers of artificial neurons to process information. It's not magic, it's math inspired by biology. But why does this matter? Because it's powering everything from your Netflix recommendations to self-driving cars. Stick around as we journey deeper into this neural adventure. Next, we'll uncover the building blocks of these AI wonders. Let's start with the basics. In your brain, billions of neurons connect through synapses, sending electrical signals to learn from experiences. Neural networks copy this. Each artificial neuron takes inputs like pixels from a photo, multiplies them by weights, adds a bias, and decides if it fires using an activation function. Sounds technical? Think of it as a party decision. Inputs are guest suggestions, weights are how much you value each, and the activation is whether you go or not. These neurons stack into layers. Input layer grabs data, hidden layers crunch it, output layer spits out predictions. Our explorer is now sketching this on a digital map, lighting up the path. It's exciting because this setup lets AI recognize patterns we can't see, coming up how these layers team up to learn. Now envision the network as a multi-story building. The ground floor is the input layer, feeding in raw data, say, images of cats and dogs. As info climbs through hidden layers, each floor refines it. One might detect edges, another shapes until the top floor shouts cat or dog. Our explorer climbs these layers, flashlight revealing hidden gems of computation. But how does it get smart? Through training. We show the network tons of examples, and it adjusts those weights to minimize errors, like practicing a skill until you're a pro. This backpropagation is the magic sauce, inspired by how your brain strengthens connections with repetition. Feeling the thrill yet? Next, we'll dive into training in action, where AI really starts to shine. Deep into our journey, training is where the action happens. Feed the network labeled data, correct answers, and it makes guesses. Wrong, calculate the loss, then tweak weights backward through backpropagation like a coach correcting your swing in real time. Over iterations or epochs, accuracy skyrockets. Relate it to learning guitar, early strums are off-key, but practice refines your fingers. Our explorer practices with virtual datasets, watching the network evolve from confused to confident. This process powers deep learning, with networks having dozens of layers for complex tasks. But challenges lurk, overfitting where it memorizes instead of learning, like cramming for a test without understanding. We'll tackle that next as our story builds toward mastery. As our explorer pushes forward, hurdles appear. Overfitting is a big one. The network gets too tailored to training data, flopping on new stuff like a student who only knows textbook answers. To fix it, we use techniques like dropout, randomly ignoring neurons during training to build resilience or add more diverse data. It's like cross-training for robustness. Another key. Activation functions, the spark that adds nonlinearity. Sigmoid squishes outputs between 0 and 1 like a gentle decision gate. RayLU lets positive signals flow freely, speeding things up. Visualizing this, the explorer untangles wires, simplifying the path. These tweaks make neural nets versatile for images, speech, even games. Get ready, we're heading to real-world wonders where this tech transforms lives. Stepping out of the lab, neural networks are everywhere in your daily life. Take facial recognition on your phone. It uses convolutional neural networks, or CNNs, specialized for images. Filters slide over pixels to spot features, eyes, nose, building up to identity. It's like your brain piecing together a puzzle instantly. Our explorer scans the crowd, AI lighting up matches with precision. In healthcare, they diagnose diseases from X-rays faster than doctors sometimes, saving lives. But it's not perfect. Biases in data can lead to unfair outcomes, echoing human prejudices. This raises ethical questions we'll explore soon. For now, feel the empowerment. Understanding this lets you appreciate the AI revolution. Next stop, the heart of innovation, generative models. Diving deeper, meet GAN's generative adversarial networks. Two nets compete. The generator dreams up fake images, the discriminator spots fakes. They push each other to perfection, creating hyperrealistic art or faces. Think of it as an improv comedy duo getting funnier together. Our explorer joins the duel, witnessing AI birth new worlds. This tech fuels tools like DALL-E, turning text to images, sparking creativity for designers and artists. But it blurs reality, raising deepfakes concerns. In our journey, this is the rising excitement, AI not just recognizing, but inventing. As we climb higher, ponder, how far can this brain-like power go? The climax awaits, with mind-blowing applications that change everything. Building to the peak, let's talk recurrent neural networks or RNNs for sequences like language. They remember past inputs via loops, perfect for predicting the next word in a sentence or stock trends. LSTM variants fix forgetfulness issues, holding long-term memory like your brain recalling a story's plot. Imagine chatting with Siri, that's RNN magic at work. Our Explorer rides the memory wave, connecting past to future. In autonomous cars, they process video frames sequentially for safe driving. The power is immense, but so are risks, AI surpassing human intuition. This tension fuels our climax. Hang on, insights are coming that will rewire how you see technology. At the summit of our adventure, key insights emerge. Neural networks excel at pattern recognition, outperforming humans in specific tasks like chess or medical imaging. But they're black boxes, we often don't know why they decide what they do, sparking trust issues. The climax, AI's potential to amplify human creativity or displace jobs. Ethical AI demands diverse data to avoid bias, transparent models, and human oversight. Our Explorer gazes at the horizon, weighing hope against caution. This brain mimicry isn't just tech. It's a mirror to our minds, urging responsible innovation. Emotionally, it's thrilling yet humbling. AI learns from us, but we must guide it. Next, deeper revelations on the future. Pushing boundaries, enter transformers, the backbone of models like GPT. Unlike RNNs, they use attention to weigh important parts of data simultaneously, revolutionizing language AI. It's like your brain focusing on key details in a conversation, ignoring noise. Self-attention lets vast networks scale efficiently. Our Explorer activates this power, words flowing into predictions with eerie accuracy. Insights. This enables chatbots that feel human, translation apps that bridge cultures. Yet the energy cost is huge, and hallucinations, wrong facts remind us AI isn't conscious. The emotional high. Witnessing AI evolve sparks wonder but calls for sustainable progress. We're nearing the end, takeaways ahead to empower you. As revelations peak, let's crystallize the core. Neural networks are layered neuron mimics that learn by adjusting weights on data, enabling AI to perceive, decide, create. From simple perceptrons to behemoths like GPT, they've democratized intelligence. Emotionally engaging? Absolutely, it's like unlocking superpowers we all can tap. Key insight: you don't need a PhD. Start experimenting with tools like TensorFlow. But remember ethics, fairness, privacy, explainability. Our Explorer nods, enlightened. This journey shows AI as an extension of human curiosity, not replacement. Feeling inspired, the finale wraps with action steps to dive deeper into this neural world. We've traversed the neural landscape, from brain-inspired basics to transformative tech. Takeaways: understand layers and training to grasp AI's learning, use analogies like neural parties or memory rides to explain it. Champion ethical use for a better future. You're now equipped to explore AI confidently, it's simpler than it seems. Thanks for joining this adventure on AI Explained Simply. If it sparked your curiosity, subscribe, and comment your biggest takeaway below. Check out our beginner guides for more. Remember, AI thinks like your brain because we built it that way. Now go create something amazing. See you in the next simplification.